Hello, SAR people. This is actually a talk that I wanted to give Wednesday night, and we ran long Wednesday night. We didn't have time to go over a lot of things, so I thought I'd just turn this into a tutorial of sorts. And all I'm trying to convey and relate to you is some background information about the FLIR Scout devices that were donated to our team by FLIR. I think this would be helpful so that when you're looking through the devices, you have some idea of what you're seeing and why you're seeing it. Dave Smith actually knows someone at Chateau Saint-Jean, the winery. So we went out there one night and did capture some video. We have done searches in vineyards and we will likely do them again, so this seemed like a good place to go. Kent has also had his hands on the FLIR for a bit of time, as well as Steve Ellis. So all of us have used them and have become aware of some of the quirks and the things to know. So any of us, you can ask any questions. So first off, a little bit of background information. What is FLIR technology? And actually what it is the capture of the infrared electromagnetic wavelength. And it captures this wavelength, detects it, processes it, digitizes it, and then puts it into an actual image that you see. And when you look through the device, what you see is almost like a snapshot of a picture, but it's a capture of heat signature of all the objects in view. It's not like night vision, so it's not dependent on light, it's dependent on heat, so it's unaffected by light. If you were out on a full moon night or a no moon night, it would not change the images that you see because they are reflective, so to speak, of heat signature. And all objects have a heat signature because all objects have an emissivity factor. And that's really the capacity of any object to radiate that heat. So some objects have a high emissivity factor, some objects don't, but actually most objects retain some amount of heat. If the surface gets warmed by the sun, they give off that heat until, of course, time has passed. And since we are talking about a heat signature, you can imagine it's affected by wind and convection. And the little graph below, actually just, it's a very short overview of just wavelength in general. Most of us are familiar with radio and TV wave, microwave. These are longer wavelengths. They're a lower frequency, lower energy. And then you have IR, which is actually right outside the visible light spectrum. And that's actually what's being captured and what we're seeing. There's UV, X-ray, gamma ray, very high energy wavelengths, very destructive wavelengths, and very short wavelengths. But what we're seeing is actually the capture of the IR wavelength. So given some of the background information that we now understand about the FLIR and how it generates its images, it seems there's a few things to keep in mind so that you can really understand what you're seeing and interpret what you're seeing and use this device to its best advantage. These are what I call FLIR factors. One of the things is the time since sunset. Since all objects have an emissivity factor, certainly the later in the evening or the more time since the sun's been shining on an object, the greater delta you will have between any of the objects and a warm-blooded mammal or missing man with a temperature of 98.6. Likewise, ambient temperature. If it's during the day and it's 90 degrees out, the delta from 90 to 98.6 is not great. Therefore, the missing man may be less distinct and harder to pick out. The density of the surroundings. Earlier I mentioned the wavelength frequency, the energy of the wavelength that we're looking at. IR wavelength is low energy, so does not have the ability to penetrate solid objects, unlike gamma and X-ray, which are more of the radioactive wavelengths, high energy, very destructive. So IR will not be able to be detected through solid objects, not through glass, stone, rock, even heavy brush. So it will be harder to pick out your missing man in dense surroundings. And fog can also be something like a dense surrounding. I did have an opportunity to look through some very heavy fog. With the naked eye, I could see out to about 50 feet, and that was the same for the FLIR device. That's all it could pick up. It had little advantage in heavy fog. However, I was able to detect a man out there at 300 feet at night in the pouring rain, so the rain droplets were not as dense a covering. Terrain and vantage point are helpful. Again, if you can be looking down perhaps and have a vantage point of that, you will be able to see a lot of the terrain. So it's worth keeping that in mind, and I'll touch on that a bit in the videos. Clothing, of course, the clothing can mute the heat signature that you have until you warm up your clothing. And one of the last things is the fact that as you look through this device, the image auto-calibrates. So it's going to detect the warmest heat signature in its field of view, but it does express everything else relative to that warmest object. So that warm object you're seeing is that 98.6. That's pretty hard to know because it will just pick up the warm objects. Also the night sky background, that can skew the heat signature because what you're looking at relative to the night sky is going to appear very warm, but that doesn't mean it's 98.6 degree heat signature. So keeping all that in mind and kind of getting used to what you're seeing and being able to interpret what you're seeing is really probably something that we're all going to have to get used to really maximize the utility of these devices. But it's very powerful technology and very enabling for sure. So before we get to some videos, a picture's worth 1,000 words, especially with something like FLIR. I wanted to show some stills that I captured at a known distance at 300 feet. So in this first picture, this is basically from my back door at night, and I know that that light is about 25 feet from my back door. There's an arbor out there that's at about 50 feet. There's a building at 100 feet, and then the back property line is at 300 feet. So this is what it looks like at night. This is what I can see. If I use the FLIR device with the white hot color palette, this is now what I see. I can see virtually everything. Everything appears as a black and white photograph in contrast, but clearly there's some very bright white hot images out there. So I can see my husband, a person standing out there. I see legs and a head, a muted upper torso. I even kind of see a hand. I see bushes, chairs, trees, all kinds of things. And presumably that's some livestock out there in the back at about 800 feet. This is the black hot color palette. So now the heat signature is displayed in black. The hottest things are black. Again, you can see that there's a person standing out there and some other objects, but nothing else is as dark as that. This is the red hot color palette. Again, intense heat signature is shown red hot. And then this is a 2x zoom, which this particular device has. So it's pretty clear that that's a person standing out there when you zoom in on them. But I did know that that was a person out there. So next I'm going to go to the videos that we captured in the vineyard. Just a couple of things to note. It was some time ago. It had been a very, very warm day, in the upper 70s at least, bright, clear sun. We were out there at 7. It was dark, but had not been that long since sunset. And we were out there for a couple of hours. But the videos really illustrate what you will actually see when you're out there. So I'll talk through some of what you see in the videos. That way, when you're using these devices, you'll have a better understanding of what you're seeing, why you're seeing it, and be able to better interpret what it is you're seeing. So please check out the videos. Okay, this is the first clip of the video we took in the vineyard. What's worth noticing here is the bright objects. Those have a heat signature. That's what we're looking for. What isn't clear is what they are, how big they are. Is that deer laying down? Is it rocks? But as you can see, after a moment, you see a guy. This is Chuck, the guy from Chateau Saint Jean, getting up and moving around. He was leaning against the rock. But as he leaned against the rock, you couldn't really make him out. When he starts to move, you can. So it's pretty clear that with the moving object, they're easy to detect. But if they're just laying there, they're a lot harder to pick out. Plus, you see all the other objects with heat signatures. So that's something to keep in mind. So here's another clip from videographer Dave in the vineyard. As you can see, it's pretty clear there's a person standing there. You can see trellises, buildings, trees, heat signature of everything, but that's clearly a person standing there. And then Dave tells me to turn around, so you can see I'm turning around. You see some variation in my shape. And then he tells me to lay down. So what you'll see is I'll be going down to the ground. And what's worth noting here is the difference between someone moving, someone standing up, or someone who just turns into a blot on the pavement. That is a lot more difficult to see, and this is where vantage point can really be helpful when you're looking through the FLIR. In this last clip, what we're really going to be looking at is the variation in contrast, the different color palettes. There's white hot, which was the first, black hot, which is what you see now, and then there's something called red hot or installer. It's hard to say which works best for somebody. It just depends on the conditions. In this particular case, you can see the warmest heat signatures are showing up in red, but this is something I really want to draw your attention to, is the red in the trees. Now that's not really that the trees are that warm, it's really because the night sky is the backdrop to that. So relative to the night sky, the trees are quite warm, but it's not that their temperature is the same as the person that you see moving towards you, and that obviously is a very bright heat signature. Also, Dave could be playing with the contrast, but the FLIR actually also goes through its own auto calibration to try to optimize the visual, the heat signature of what you're looking at. So again, here's something that's white hot, everything else looks pretty dark, still some bright spots back there, heat signatures, and then it will go to a black hot, and then in this case your heat signature is black, everything else looks very washed out, and then of course the last thing is the red hot, the installer, which you saw. So hopefully those videos really gave you an idea of what you will see. It's very clear that these are some powerful images you can see if you have an understanding of what you're looking at. Once you have that in mind, we find ourselves with some very powerful tools that we can use. And they're very easy to use. Actually, the operation of FLIR, there's an on-off switch that's near one end. In the middle, there's a brightness button. You can click through about 5 levels of brightness. The button below that is the color palette. This is where you would pick white hot, black hot, or red hot, and in any one of those color ranges, you can then step through the brightness. The button below that on this particular model is a 2x zoom. I believe the 240 has a freeze frame. Again, these are monoculars, they are not cameras. So what you see looks like a camera, but you will not be able to record a still or video unless you attach a device to it, which is actually fairly cumbersome and a bit, we don't need to do that. We just need to be able to look through them. We are going to have what we call scout assignments. And that's just the way these will be used. Optimally, we think we'll use these at late night or very cold daytime temperatures. It's pretty obvious that the colder it is, the more distinct a missing person or warm-blooded mammal is. So that's most likely when we would use them. We hope the team placement will be strategic. That's when we can take the most advantage of the technology. These may not be assigned with ground pounders, TBD, we'll see, but ground pounders are typically going through some heavy terrain, brush, focused on safety and just keeping themselves an awareness of their surroundings without having to scan and look further afield. And lastly, these will be under the purview of the equipment team, how they're kept, where they're kept, etc. That will be up to those guys to determine. Just a few of the specs about the two devices. Probably the most interesting spec, in my opinion anyway, is the detection range. So the 240 can detect a man, that's what the detection range is, out to 350 meters. The 320 can detect a man, again standing in open field, out to 550 meters. That is a long way off, but definitely at any nighttime endeavor, these are a huge advantage. This is really enabling technology we were fortunate to have donated to us. So any questions or comments? As I mentioned before, Dave, Kent, Steve, and myself, we've all used these, had our hands on these, maybe a little bit more familiar with what you see and what it means. For questions about practices, how these will be handled, that's likely to be determined by XCOM and the search managers. And there is a very brief operating manual on D4H under Intelligence, Documents, and FLIR. So that's it, folks. Thanks for your time. Hope I didn't bore you to death. Stay dry, and for everyone who's coming out Sunday night for the training, we hope to have the FLIRs out there, give everyone an opportunity to find the missing person, and get a chance to look through these, use these, and begin to become familiar with how they're used. Thanks, everyone, and see you soon. Bye.